Imagine if everything we thought we knew about the universe was based on a map, a really detailed map, but one with a giant, mysterious tear right down the middle. Well, today, we're going to take a look at that map, a physicist's map of reality. And we're going to see that it's full of incredible detail, but also contradictions, huge blank spots, and some absolutely fascinating mysteries.
You know, it all really boils down to one single question. This is the big one, the question that gets every physicist out of bed in the morning. How does this whole thing, the universe, actually work?
No, to even start to answer that, we have to face a huge problem right at the heart of physics. Turns out, our beautiful map of reality, it's kind of split into two completely different pieces that don't talk to each other.
And this slide, this shows you that divide perfectly. Okay, so on one side, for the really big stuff, we're talking planets, galaxies, the very fabric of spacetime. We've got Einstein's general relativity. It's our master theory of gravity. But then, for the unbelievably tiny stuff, the subatomic world, we have a totally different rulebook, quantum field theory. And the problem? They just don't play nice together. I mean, they're fundamentally incompatible. When you get to a place where you need both, like inside a black hole where gravity is insane and the scale is tiny, the math just breaks. It spits out nonsense. And that's a huge problem. Because reality shouldn't have two different sets of rules.
So, even with that giant conflict hanging over our heads, we've actually managed to piece together a pretty amazing map of what's out there. So let's take a look at what we actually know, starting right from the beginning.
Our universe's story kicks off with the Big Bang. Space-time just explodes outwards, filled with this hot, dense soup of energy. Now, as things start to cool down, this weird, mysterious stuff we call dark matter begins to clump together. It forms this massive, invisible scaffolding across the entire cosmos, what we call the cosmic web. Then, all the normal matter, the stuff that makes you, me, and the stars, gets pulled by gravity into these invisible filaments, lighting them up with all the brilliant galaxies we see in the night sky.
Okay, so what is all that stuff actually made of? If you could zoom in, and I mean way in, as far as we can possibly go, you'd find these, elementary particles. And the name really says it all. As far as we know, they're not made of anything smaller. This is it, the bottom floor. They are the absolute, fundamental building blocks of our physical world.
And all those little particles, they only interact through just four fundamental forces. You've got the strong force, which basically glues the centers of atoms together. There's electromagnetism, which gives us light and all of chemistry. The weak force is in charge of certain kinds of radioactive decay. And of course, there's gravity, which shapes the entire universe. But notice something here? The first three forces have a particle that carries the force, the gluon, the photon, the W and Z bosons. But for gravity, the graviton is still just a theory. We've never actually found one. And that one missing particle, it's one of the biggest holes in our entire map of reality.
And that missing graviton? Well, that's just the beginning. It's time to venture off the edge of the map and explore the truly giant blank spaces in our understanding of the universe.
I mentioned it earlier, right? This invisible stuff that literally shapes our universe. So it's the obvious question, what in the world is dark matter?
You know, the mystery of dark matter is just wild. We can't see it, we can't touch it, we can't detect it in any normal way. The only reason we know it's there is because we can see its immense gravity bending and shaping entire galaxies. It's like a cosmic ghost. It just passes right through everything, completely ignoring light and pretty much all the other forces. Our best guess is that it's some kind of totally new, exotic particle that our current theories just don't have room for. And that brings us to the very short, very honest, and kind of humbling answer. We just don't know. And believe me, dark matter is just the tip of the iceberg. Physicists are staring at a whole list of enormous questions. How do we finally stitch together relativity and quantum mechanics? What is this dark energy that seems to be pushing the universe apart faster and faster? What really happens inside a black hole? The list of what we don't know, it's long and it's profound.
So, with all these colossal mysteries, you have to wonder, how do scientists make any progress at all? How do you even begin to redraw the map when you're sailing in completely uncharted waters?
It's a really good question, right? I mean, when the frontier is this murky and confusing, how does the scientific community decide what's a real lead versus what's just a wild guess?
Well, progress isn't just about random ideas. The hunt for new physics is really triggered by specific alarm bells. An alarm goes off when an experiment gives you a result that your theories absolutely cannot explain. An alarm goes off when we look out into the cosmos and see something, like dark energy, that we have no explanation for. And sometimes the alarm goes off right inside our own theories, when they contradict each other. telling us that our map has a fundamental error. And all of this leads to a really critical idea. On one side, you have the properties of nature. These are the raw facts of the universe, things like mass and charge. They just are, whether we're here to measure them or not. But on the other side, you have the laws of nature. These are our descriptions, our human-made mathematical frameworks that try to describe the patterns we see. It's the ultimate difference between the territory and the map. And the most important rule is to never, ever confuse your map for the actual territory.
So once you start thinking that way, map versus territory, it pushes you toward a much deeper, more philosophical question. Are we really discovering an objective reality out there? Or in some strange way, are we creating the reality that we're able to perceive?
And this is where things get really mind-bending. The physicist we're drawing from argues that the scientific method itself might not be a perfectly clear window onto objective reality. He suggests it might belong to a different layer altogether, a layer of subjective, human perspective and interpretation.
Let's just break that down for a second. Think about it. Step 1, observation, is already filtered through our human senses and the limits of our instruments. When a scientist comes up with a hypothesis, that's an act of human creativity, intuition, and it's even shaped by their prior beliefs. Then, interpreting the data from an experiment requires human judgment to figure out what it all means. And even the final step, peer review, is all about getting a bunch of other human experts to subjectively agree that the work is solid.
So, what's the big takeaway here? It's that science is without a doubt the most powerful tool we have ever invented for understanding the universe. But we always have to remember that it is a tool created by and wielded by very human minds.
And that leaves us with one last big, mind-bending thought to chew on. If our entire scientific map is drawn from a uniquely human point of view, what does the true territory, the reality we aren't even capable of seeing, actually look like?